Hello again. Algebra 2 class, this is section 4.5 that we're talking about using factoring to actually solve some equations. There are several vocab terms here that basically all mean the same thing. Zeros, roots, x-intercepts, solutions, and factors all derive from the same idea. And the key one is that word zero. And the whole idea of these, remember the function box, if you throw a number in, let's say we have a function box, we throw 7 into the box, and a 0 comes out the other side. That means we call 7 a zero of the function. And if you think about the ordered pair, 7 is the x, 0 is the y. The point 7, 0 is on the graph. Well, 7, 0, that's an x-intercept. They all mean basically the same idea. So we're going to talk about how to use factoring to solve these equations. But keep this in mind. You've got three basic situations with a quadratic. You have two solutions, one solution, or no solutions. So,
Mr. Shane Martin to the high school office. Mr.
just
Shane
like
Martin.
you were here. Because you've got three different graph types, it looks like two solutions, one solution, no solutions. I'm going to tell you that we're going to lead to this later on in the chapter. There's always two. There's always two. Even if you can't see them, there are still two solutions. So even though graphs can help you find them, graphs can't always help you find them. So we have to know all the different ways and techniques and tricks to finding these solutions. We start with factoring, because factoring works pretty well. Let me show you how to use factoring with this right here. And the answer key has these well worked out. So if you miss these, or I don't know, I'm not sure I'm going to do this one for you because it'll take a lot of time, and I spent a lot of time in the last video doing the AC method. But the general idea is, if it's set equal to 0, I can factor it well and then use the zero product property. So this right here, I'm looking for numbers that multiply to be 18 and subtract to be 3. I believe the two numbers that multiply to be 18 and subtract to be 3 are 3 and 6. To multiply to be a negative 18, one of these has to be negative. 6 is bigger, it gets to carry the bigger sign, or the middle sign. So we have this equals 0. Now if I'm thinking of two numbers that multiply together that equals 0, I know that one of them has to be 0. So that means that either x minus 3 equals 0, or x plus 6 equals 0. Solving each of these is going to give me solutions of 3 or negative 6. And if I show you that on a graph, if you graph this thing, even without the equals 0, you can see that you've got intercepts of negative 6 and 3. Is that what we had? Negative 6 and 3. Those are our two solutions, and that works pretty well. So negative 6, good. Negative 6 and 3. What if I want to do one like this? It's already set equal to 0, but it doesn't have a number like the 18 here. Well, that's fine. That means it's going to factor out pretty nicely. Check this out. What is in common between these two terms? Looks like a 2x. 2x times what gives a 6x squared? 3x. 2x times what gives a plus 4x? That'd be a plus 2. These factors multiply together to equal 0. That means either 2x equals 0 or 3x plus 2 equals 0. That means x equals 0. Subtracting 2 divided by 3, we have negative 2/3. Those are my two solutions. You'd see those on a graph as well. Check the answer key for this one right here, and it works pretty slick. Let me suggest to you that you could use tables to solve these, but honestly at this point it's probably more efficient to do either factoring or graphing. So if you see a question that says use tables, just use either factoring or graphing. When you see questions like this where it says solve by graphing, just type these things into Desmos as you see them, and you'll be able to find the solutions. That takes us to this question here. deals with the path of a baseball. And everything with quadratics is going to be following the path of a parabola. Sorry, anything going through the air is going to follow the path of a parabola. And in this situation right here, they've given us the function. And if I take that and type that into a Desmos, we can see after adjusting the window that it goes in this kind of path. So if you want to sketch that onto your notes, which I will do for you, just like so. If we sketch that right there, we can pull from that just about everything we need. We can see that it starts at 0, 0. Let's pretend we're not golfing here, that it wasn't on the ground. Technically, this probably should have started a little bit higher, right? That's okay. We can see, though, that it hits the ground, the height of zeros when it hits the ground at 385 feet. And what was the highest it got to? Well, the height was 74.12. So how far does it travel before hitting the ground? Looks like it travels about 385 feet. How high did it go? Looks like it went as high as 74 feet. What is a reasonable domain? Remember how before we said that quadratics have a domain of negative infinity to positive infinity? Well, that doesn't make sense in this context. A better domain might end up being something like from 0 to 385, right? And maybe a range could be something like 0 to 74 feet, because that's what this ball actually does. So feel free in word problems to adjust the domain down, just like you have to adjust the window in your Desmos screen to be able to see everything that's going on. All right, that's it. If you have any questions, feel free to send me an email. See ya.